Hello everyone. So now we understood what is bucketing and why it is so efficient and how it improves the performance. So we had few issues with the partitioning, that data was not equally divided. So we may have large data in few, partition, and we may have small data in few partition. So if we hit the less number of data partition, then we can get the good performance. But in case if we hit the large data partition, then in that case our query may take some time. So and that is why bucketing comes into the picture. So in my partitioning session, we created the partition table, and we loaded the data into the table. So now we can have a look once, and then we will create a table, and we'll bucketing table, and we'll load the data into the table, and then we can compare both the tables. So first we can look what is there in the partitioning table. Okay, so we need to go to the Hive warehouse, which is there in this location, user Hive warehouse, and inside it we have one database called demo hive, and its extension is .db because it's a database. And here we have this table which we created in our partitioning session. Okay, so here we have in this table we did the partition on category. So we can take any partition, suppose let's say this one. So we can see we have only single file here. Okay, because data gets divided into partitions, and all partitions have a single file. Okay, so now if we execute the query which belongs to puzzle partitions, then it will directly hit this partition, and it will ignore rest all other partition. So in that case we are not scanning whole data set. Okay, so this was the feature of partitioning. So we can improve the performance, but data can be large in few partition, and in few partition we may have less data. So in that case data is not equally divided, so still we may get some performance issue. Then bucketing comes into the picture. So now let us create the one table, bucketing table, and then we'll compare why bucketing is so efficient. Okay, so our database is demo hive, and before creating partitioning and bucketing, we need to set few properties. Okay, so here first we are enabling partitioning, then bucketing, because we need to set these properties, then only we can create partition table and bucketing tables, and we can take the advantages of their features. Now we have set the property. Now we'll create one bucketing table. So here you can see, this is the script. Now create table name transaction by part bucket. It means it's a partition and bucketed table. Okay, So we have all the columns. We did not define the category column in the column list because it's a partition column, and we understood this thing. The column on which we are creating the partition, we don't need to define that column into the column list. Then cluster by state. So in the partition table, we are creating 10 buckets. On which column? On state column. So suppose for category puzzle, if we have 100 records, okay, for and few 100 records, so it will create the 10 buckets inside this category folder. Okay, here it will create the 10 files, not the folders. Bucketing always create files, and partition always create folder and then one file. So category will be the folder, category n equals to the category name, and inside that we will have 10 files. So each bucket will contain the equal number of records based on state. Okay, so suppose in category we have 100 records, and few belongs to other state and few belongs to other state. So all 100 records will get divided into the 10 buckets. So each file will contain 10 records. So in that case, what happen when user fire a query where he or she mentioned category equals to puzzle and state equals to suppose something like Texas or anything. So it will hit only that bucket in that partition, in that particular partition where that actual data exists. It will not scan whole table, even it will not scan whole partition. Okay, so that further improve the performance, because now data is equally divided. So we have overcome that issue which we had in the partition table. So few columns can have multiple data, more data, and few partition can have small data set. But now all data set, whatever it may be, whether it's a huge or it's a small, all will get divided into the number of buckets. So now when user fire a query, the query will scan only that particular bucket instead of scanning whole partition data. And the rest of the things are same. Row format delimited, fields terminated by comma, and stored as a text file. The only for bucketing we just need to remember the cluster by the column on which we want to create the bucket and into the number of buckets, how many buckets we want to create, and we need to set these property true. Set Hive.enforce.bucketing equals to true. So let us create this table. It's created. We can see the schema of it. Okay. So category is the partition column. So it is coming at the end. Okay. But by looking at the schema, we cannot get it's a partition, it's a bucketing tables or what. But we have one command, describe formatted. So it will provide us more information about this table. So here we can see if we have bucketing information. Yes, here we can see we have number of buckets 10, bucket column equals to state. Okay, so if we see if we want to get the full information about table, then we can use formatted clause, describe, formatted, and table name. Here we can get the partition information also, on which column we have created partition, on category, which is the string type. Okay, so now we will load the data into this table. So to load the data into the partition table or in the bucketing table are same. We don't need to mention anything for bucketing, but for partitioning we need to mention the category column here. The same thing we did in the when we load the data into the partition table in the last session. Okay, so now we'll execute the same query, but now here we have changed. Here we have created partition plus bucketing table. So it is loading. So Hive also executes MapReduce internally. So now we can see it is executing. So map is started 0%, reduce 0. Now reduce is started 10, 20. So once it is done, we'll have whole the table will be loaded with the data, and then we can see in the Hive warehouse we have 10 buckets in each partition or not, and then we can compare with the data in the warehouse for partition table and for bucketing tables. So we can see the difference. %, so it is about to complete. So it's completed. So now we can see first it loaded category data and then bucketing data. Here we can see 60 rows loaded to in this table. Okay, so now we can check that we have data or not in this table. Select star from this table then. So we can see we have data now, and now we'll go to the Hive warehouse. So this is the partition table. So we have only single file. Now for bucketing, we need to use this table, transaction by part bucket, and then we can go to same category, so we can compare. Okay, so this is the partition table in the warehouse, and this is the bucketing table. Category is same, puzzles. So now we can see we have 10 buckets inside the bucketing table. So now if user fire a query and data exists in any particular bucket like 4 in this bucket, then it will scan only this bucket, not all buckets. Okay, so now data is equally divided, and here whether but in the case of partitioning, the query will, the Hive engine will scan whole data in that particular partition. So a few partitions may have large number of data, and a few partitions may have less number of data, but with the help of bucketing we can still divide the data inside this partition. Okay, so now we can see how effective it is and how it can improve the performance internally. Okay, so now we understood the partition concept, we have implemented the same. We understood bucketing concept, we implemented the same. So we are done with the partitioning and bucketing in Hive.